Hello everyone, welcome back to LeetCode Daily Live, where I do the daily question raw and uncut. So we have an easy today. It's called Count Good Triplets. So let's see what the question wants. And let's look at the parameter first. So we have an array, which is a list of ints. So yeah, because it is an easy question, the bounds are small and the actual values are also not too big. We are also given three integers, which could go from 0 to 1,000. So let's see what the question wants. Yeah, so this is what we are given. You have to find the number of good triplets. So yeah, because length is 100, we can actually just brute force like everything. So a triplet is good if the following conditions are true. So we have 0 all the way. Wait. I think this is the so the triplet has to be like they have to be different indices, but then it also has to be ordered. So like 0, 1, 2, we don't count like 2, 1, 0 basically. And okay, so it's just like the distance between the triplets can't be over ABC. So we want to return the number of good triplets. Well, yeah, I'm just going to brute force this. I think there's an n squared solution, which is like if you sort all the numbers and then you look at each pair, you can kind of you look at each pair and then maybe I'll draw it out actually. So something like 0, 1, 1, 3, 7, 9. So this is looking at the first example, right? Yeah. So if you look at the first triplet, well, we can basically we can just look at the first element and then we can choose um we can choose the second element, but the second element has to the absolute value has to be like small or equal to a, right? So there are only so much we can choose up to, but then for each one we can actually do it in log n time, I think. Oh, so it would be like n squared log n time complexity, because you can find you can use bisect to find let's say for 0, 1 and like wait, actually, is that even true? Yeah, I think because there's this has to be less than C, this has to be less than B. So just find the minimum of these and then you can bisect. But this doesn't really concern us for this question because we can because a n cube time complexity solution would work just fine as well. So yeah, let's code it out. So for I in range, so we want to go from actually, yeah, let's get the length of the array. So we can do this first, and then so we want to go up to n for j in range. So we want to start at I plus 1 and all the way up to n, and then for k we want to start at j plus 1. So that's going to generate all the triplets, which is ordered as well and with different indices. So what we can check is we should also have a count outside. So what do we want? So if the absolute value of array I minus array j is smaller or equal to a, and the absolute value of array j minus array k is more than b, and the last condition would be array I minus array k is less than c. So if all of these are true, we found a good triplet. So at the end we can just return count, and I think that should work. Yeah, nice. Yeah, so I think this peak would be the n square solutions. Oh wait, actually, this is not really n squared, but they're doing the check earlier to get rid of like unwanted ones quickly. Yeah, okay. Yeah, that's something to learn. Like doing this, like the early exit will make it faster. And yeah, thanks for watching, and I'll see you tomorrow. Bye.